So, I'd just like to introduce myself. My name is Dan White. I'm a Partner Solution Architect Manager for the UK and Ireland. So my role as a Partner SA is to help our partners grow and improve their technical capability on AWS. I'm delighted to be joined by Richard Potter today, so I'll let Richard introduce himself.
Yeah, hi everyone. Great to be here. So I'm Richard Potter, CEO and one of the co-founders of a business called Peak. We are one of AWS's machine learning competency partners, but we're also the creators of the enterprise AI system category, which we're going to talk to you a little bit about today.
Great, thanks Richard. So to kick things off, we live in a world today where we expect everything to be available instantly. You go online, you order an item, you expect it to be in stock and delivered next day or within hours. You also expect to get recommendations about things you might like. And this transcends lots of different industries. You maybe watch a film on Netflix. You expect to get a personalized service where you get a recommendation about films you might like as well. So we have really high expectations on the level of customer service that we expect. And we expect that service to be hyper-personalized. So it's a service that really understands you as an individual, and it's tailored to your individual needs. So what I want you to think about when we start this presentation is, with your customers, do you really, truly connect with your customers? Are you truly understanding them and giving them the best possible service that you can? And what we're going to do is we're going to show how Peak worked with two customers and helped them provide that hyper-personalized service to their own customers. In terms of the agenda, I'll keep it quite simple. I'll start off by talking about two problems. The problems are for me as a consumer and for the businesses that serve me. And then I'll talk about how Peak met these two businesses and helped them solve those problems using AWS. And then we'll finish off, Richard will summarize the outstanding results that were achieved with those customers. So we're seeing some pretty amazing things with machine learning at the moment, but we still have lots of difficult problems to solve. So this is problem number one. This is my car. It was born in 2006. It's done around 250,000 kilometers on the road. Passenger door is a little bit dodgy. It's kind of just hanging into place, but it's not great. I lost the rear windscreen wiper a couple of years ago. We had some really heavy snow, and it kind of started halfway, and then it just snapped off. So it's fair to say I've had quite a difficult relationship with this car over the last 6 years. I had some fantastic news in June of this year. It was stolen from my drive. This was one of the best things that happened to me in the relationship with this car. Then I had a phone call with the insurance company, and they offered me 10 times the value of the car. They didn't realize what a state it was in. So that was the best thing that had happened to me. Unfortunately, a month later, it was found in perfectly good condition. There was no damage done to the car. I had to pay £200 to retrieve it from an impound. So it wasn't a very good outcome for me. Now, to help me define this first problem, I'd just like a bit of participation. Could you tell me if you know the dates that your car insurance is due for renewal? So can you raise your hand if you know that date? Okay, there's a few very well-organized people that know, but generally most people don't know that date. How about the date for your car tax? In the UK, we have an annual car tax. Okay, quite a few of you know the car tax. Still only maybe a third of the room. What about your annual car safety check? So in the UK, we call this the MOT. I think in the US, you have a car safety check every year. Does anyone know the date for that? If you raise your hands if you know. Okay, again, maybe about 30%, 25%. What about the car service? Do you know when your car is due for its service? Raise your hands if you know. Okay, so again, quite a small number. So wouldn't it be great if you had a personalized service that could provide you with a nice, easy dashboard that told you all of those dates, understands you as a customer, but even better, it could make recommendations to you. So thinking back to my car, it would have been great for me to have a service that could make recommendations about the best time to sell my car, look at trends in the value of my car, and help me manage all of these key pieces of information. Okay, problem number two. These are my trainers. They were born in 2012, done around 12,000 kilometers, no insoles, never been stolen, unsurprisingly. Now, another bit of participation. Could you raise your hand if you like shopping for trainers or clothes? Anyone like doing that? Anyone enjoy that? Okay, so a pretty low number, same as me. So what if you had a personalized service that understood you as a consumer and could make recommendations to you about the best trainers or the best clothing that was based on your personal preferences? It was meaningful information that related really well to you. So you had that personalized service that helped you avoid making the wrong decision as well, like that. I don't think these shoes are quite so bad in Vegas, but where I come from, it's considered to be a bit of a fashion faux pas. So it's about avoiding those decisions, having a service that really understands you as a customer and makes the right recommendation to you. So who can help? In terms of my car problem, we have an organization in the UK called Regit, and they're basically a one-stop shop for motorists. They provide a digital garage where you can get all the details about your car. But they had their own challenge in terms of understanding me, their customer. And then in terms of the trainers, we had a clothing retailer called Asylum. Not only do they sell trainers, they sell clothes as well. But again, they had their own challenge. And both of these customers, they came to Peak for help. And Richard's going to now describe the background issues that they had and why they came to speak to Peak.
Thanks, Dan. Okay. Let's talk about Regit first. So, as Dan's said, they're a service for motorists in the UK. Relatively young organisation, 10 years old. They help you manage your sort of motoring needs through a digital garage, as Dan described it. Digital car management, really. They have 6 million customers, which is decent considering that's a good chunk of the UK driving population. What they do as a business is they provide leads to the automotive industry. So they give car manufacturers, dealerships, and so on, qualified leads to help them drive their own sales, and they make commissions on the leads that they pass through. They came to us with a really interesting challenge, which was they've got 6 million customers, and they've got a lot of data on those customers, but they felt that they could do more with that data. They felt that they could use some of that data to predict things about those motorists, and then make the right recommendation to those people at the right time, and therefore provide better leads to their own customers. So that's essentially what we embarked on, the challenge we tried to address. Could we predict things like when is someone likely to change a car, what car are they likely to change into, and so on and so forth. So that was challenge number 1. And number 2, Asylum, as Dan rightly said, they're one of the UK's leading high street fashion retailers, specifically focused on sportswear, street fashion, you might call it, similar to Foot Locker. They are an organisation that started life in 2005. They've already grown to having 65 stores. They turn over $250 million, £200 million annually. I suppose their challenges, really, you can isolate it down to a really, really interesting one, which is that they felt that there were tribes around the UK, around the country, of different types of customer. So they gave their in-store managers the freedom to dress the windows and display products that were relevant to the local audience. But recreating that experience online and digitally is obviously much, much harder, but not with machine learning. So we're going to talk to you a little bit about how we can drive those hyper-personalised, regional specific recommendations to individuals using machine learning and what we've done with Asylum. But I'll hand back to Dan to talk you through some of the technical challenges in trying to address those 2 problems.
Thanks, Richard. Okay, so both of these customers to Peak kind of had common problems, really. They didn't know how to gain intelligent customer insights. And as mentioned at the start, the businesses that have really progressed in the last 5 to 10 years, they make intelligent use of their data so they truly understand their customers. And they also use hyper-personalization. So that's this ability to provide a service that is personalized to specific individuals. It's not generalized in any way. So the solution, solving the challenge, was for Peak to use their AIS solution using machine learning on AWS. But machine learning isn't easy. So for a start, you need huge amounts of data, and your machine learning algorithm is only as good as the data you put into it. But I'm sure plenty of you in the audience who've been involved in projects, sometimes the biggest problem is getting the data and using it and getting good quality data. So you have these legacy ERP systems, been around for a long time, format's not great. You have data silos. You have to contact various business owners to get the data and integrate it as well. And then you have data warehouses. I don't know about you, but my garage, it starts off tidy. When you put everything, you've got good intentions, and as the years pass by, it just gets more and more cluttered and disorganized. And I kind of think of data warehouses in a similar way. Over the years, the quality of the data can degrade. There can be missing data. There's duplicate data. The format's not great either. So you've got a lot of challenges there when you start your machine learning projects. You also have to convert those business problems into a machine learning problem. So bear in mind that the machine learning algorithm you use, it's essentially a series of functions to solve a numerical problem. So you've got to convert those business problems that we mentioned into that machine learning problem. First thing you've got to do is you've got to collect the data, and you'll have multiple sources of data throughout the customer. And then you need to integrate it. So you run an ETL process or pipeline process to integrate that into a single data set because your algorithm needs to have that data presented in the right format and as a single data set. You then need to prepare and clean that data. So as mentioned with the data warehouse, it can be in a real state. There can be formatting issues. There can be duplicate data, missing data as well. So you need to go through that sort of data wrangling process where you've got to clean it into a state that's ready for your data scientists. And all of this takes a lot of underlying effort. You have to have the right tools to ingest that data. You need to ensure it's handled in a secure manner and you're security compliant. You also need to have highly scalable storage because often you're dealing with huge amounts of data as well. And then you need a really good, highly scalable ETL tool to do that unification process, to unify those data sources into a single source. You then move into the model training phase, or at least the initial data analysis phase. So this is where your data scientists get involved. And the first thing they need to do is to start looking at that data in more detail. So they can start to analyze that data. What they're looking for is patterns in the columns of data that are going to help them make a prediction. And they often will use tools like Gipsy Notebooks or RStudio. And this enables them to delve into the data and try and look for the patterns. And then there's a process of feature engineering. So think about the features in a car. You can differentiate cars based on features like the engine size, the engine type, whether it's a petrol or a diesel. All these different features help you determine the differences between different cars. But machine learning models need numerical vector data, and a lot of this, the data you might have, like the model of the car, isn't any use to the model. It's categorical data, so you need to have the ability to convert that into numerical data. And you might have some features that need to be derived. So you have derived features where you get two different columns of data, and you create a new feature. So think, for example, the age of a car. So you might have the date of registration of the car, but you haven't got the age of the car. So you can create a new column of data that subtracts the date of registration of the car from today's date to give you the age of the car. So this is about creating new features. It's this feature engineering process. You then get to the model training stage. This is where the data scientist needs to decide what's the right algorithm to use to help solve this problem. But also, they need to tune those hyperparameters. So does anyone remember in the 90s, early 2000s, you had, on a hi-fi, you had the graphic equalizer settings? People remember that? Yeah, so there are some people as old as me. You could adjust all of those different graphic equalizer settings to get a different sound to your music. And I kind of think about hyperparameters in the same way. So hyperparameters are all these different values you have for your machine learning algorithm, and you can tweak each of those values to get a different accuracy of your model. So the data scientists can spend a lot of time tweaking those different hyperparameters to get a better model accuracy. And it's a very iterative process. You can be going back around in circles, changing those hyperparameters, and then retraining your model. And then it's time to evaluate that model. Is it meeting the business needs? Is it going to enable you to make accurate predictions? And you have to consider other things as well, like overfitting. Has anyone heard of overfitting? Yeah, cool, couple people in the room. So good way to describe overfitting is if you are studying for an exam and you only have a limited amount of practice questions, you're not going to do as well in the exam if you've got a very small amount of questions and you've learned about those questions. You've maybe not necessarily learned about all the concepts that you need to learn about, and then you get to the exam and you won't get as good a score because you've had a very limited set of practice questions. And I think about overfitting in a similar way, in that the model has become so well trained for the data that it isn't able to generalize to new data and make predictions on that new data. So there's a couple of things you can do here. You can use holdout validation, where you could split your data set into, say, 70% for training, another 15% for your validation, and then 15% for your test data set. So it's an unseen data set that your model can then make predictions on. This is just one of the things that they have to consider. Now, quite often, well, in most cases, the business goals won't be met first time. And as mentioned before, it's an iterative process. You need to go back, potentially change some of the features, create new features, alter some of those hyperparameter values as well. And all of this has a lot of underlying work that's required. So think about the Jupyter notebooks you need to create for your data scientists. The underlying compute needs to be highly scalable because some of these training jobs are pretty intensive. You may need to create data connectors when you're doing that visualization stage and analysis. And you've got lots of algorithms. So there'll be multiple algorithms you could be using. You need to be able to store those securely and distribute them as well. You need the ability to scale. And you may have multiple data scientists working on this particular project. So you need to be able to distribute this to those multiple data scientists. In some cases as well, think about the customer engagements you work with. You often find the customer will have additional data that suddenly comes to light, or they've subscribed to some new data. So you could have new sources of data that can help improve the accuracy of your model. And you go back through that process again, you collect the data, unify it, ingest it securely, and prepare and clean it, and go back around this cycle of the visualization, feature engineering, training, parameter tuning, and reevaluate that model. So you're back around that step as well. And then ultimately, you've got a model that you're happy with, and then you can think about deploying it. And the first step you need to do is you deploy to an endpoint. So you can either use a custom application or just make a post call to that endpoint to get a prediction from that model and see how accurate it is. So we spoke about holdout validation. Putting that data to one side, that test data, the first thing you would do is use that test data to make a prediction. Then hopefully, if you're happy with it, you can deploy it for production. In many cases, you might need to go back to the drawing board. You might need to go back through the training phase, get more data, change more features. There's a number of things you might have to do. And you're constantly getting feedback as well on the performance of the model that you need. You need to be able to debug that model because data changes over time, and the performance and the accuracy of your model can degrade over time as well. And ultimately, you need to be comparing it with the ground truth data. So when you made your predictions, how accurate were they? What really happened? What was the real outcome? And you will often get additional data sets from your customer, so you can retrain your model and produce new models that could be more accurate. So all of this is underpinned, again, by a lot of effort and work in terms of the compute you need to provide. You need to be able to scale, so when you're dealing with production workloads, You need that ability to scale up with the spiky demands of that workload. You need to have a good deployment method so you can easily automate and deploy all of this. You need version control because you'll have multiple versions of your model as well. And of course, as mentioned before, you need to be able to track the performance and you need to be able to debug your model to make sure it's performing well and the performance isn't degrading as well. So in quite a long-winded way, I hope I've sort of got the message across that machine learning isn't easy. There's lots of steps, and you'll be following this process, and you loop back around this process multiple times. It's a very iterative process, and it's difficult. It's a difficult process, and there's a lot of underlying tasks you need to carry out to support this and to support your data scientists. So Richard will now talk briefly about how Peak can help with their offering, their solution on AWS. So I'll hand over to Richard.
Thanks, Dan. Yeah, so fortunately, it doesn't need to be as hard as that. Let's just talk a little bit about Peak and what we do. So as I said earlier, we've created what we think is a new kind of enterprise product category in the enterprise AI system. What it needs to be able to do, this system, is, I suppose, provide three really core components that would go to solving some of the complexity that Dan has just outlined. The first is obviously it needs to provide the infrastructure, so the storage, the compute power, the scaling, the security, and all that goes with running machine learning and AI in production. The second thing it needs to be able to do is to support the data scientist and the engineer through the workflow of going from raw data and ingesting that data, doing all the things Dan just described, and then making it available at an endpoint such that it can be either displayed in a dashboard or taken to another system and used in production that way. And the third thing that an enterprise AI system should do is it should provide machine learning and business solutions. Machine learning solutions can be out-of-the-box models, specific to certain tasks. Business solutions can be out-of-the-box solutions for hyper-personalization for marketing, forecasting, those kind of things. And if you have one dedicated system that can do all of those things, you go a long way to simplifying the process that Dan has just outlined. One of the reasons it's important, and we think it's very important, is that machine learning and AI, as we see it, are so core to every enterprise, both now and in the future, that you'll see the emergence of new kinds of business system. And we see this as the first kind of intelligent business system that sits at the heart of every enterprise. And we think that instead of distributing machine learning around your architectures, you should centralize your data and centralize that intelligence in one system. So let's just look at some of the features of the Peak system. It's a single cloud-based platform that incorporates a lot of AWS's services, including SageMaker. It has to do quite a few things very, very well. It has to be able to ingest data from any source, connect to other systems, pull it in. It then has to be able to transform and unify that data in a way that then supports the data scientist and the engineer to train models and algorithms. And then, of course, you must be able to do the training, manage the machine learning process, and orchestrate and enable the management of that continuous workflow, which is a feedback loop, as Dan described. And then finally, an enterprise AI system like Peak's should be able to connect to other business systems. And if you think of it as a central brain at the heart of your enterprise that then can power all the other dumb products, as I would call them anyway, to be smarter. So I think you should have one system that makes intelligent decisions and predictions, and then it should connect to your CRM system or your email marketing system or your ERP system and power those traditional products to be more intelligent. So that's what the Peak system does, and that's how we've gone about approaching the two customer challenges that Dan just outlined. So we're going to talk a little bit about now how, in incorporating SageMaker and other services, the behind the scenes has been simplified greatly. Okay, so
thank you. Yeah, so I'll just very quickly talk through the machine learning stack. This slide's out of date already, if you've seen the announcements over the last couple of days. But at the bottom layer, you've got the frameworks that are available, so you can work directly with those frameworks with the interface is available, they're packaged AMIs. And all of this is running on AWS, so you've got access to data lake storage, you've got the scalable compute with the P3 instances, for example, a number of different security tools as well, and the big data analytics capability. At the top layer of the stack, there's a series of pre-trained application services where we've done the machine learning and the deep learning for you, and you can just use your application to make an API call to these services to enable you some artificial intelligence across speech, vision, and language. And then the platform layer, this is what we're really focused on. So at this layer, we've got Mechanical Turk, which enables you to recruit temporary workforces to get some human intelligence to verify some of your training, but also to be able to provide some ground truth data to you as well. And you saw the new announcement about the new ground truth labeling that you can use, so SageMaker can tap into that. And then we've got SageMaker, middle of the stack. So this is about taking away all those underlying tasks and enabling your data scientists to focus on the things that are most important, the actual data and solving the problem, developing that model. So in terms of the components, you have an environment that enables you to build your Jupyter notebooks, build your models, train and manage that training, and then manage that deployment and hosting as well. You can use our own built-in copies of multiple different algorithms, like XGBoost, random cut forest. There's about 15 now that are supported. You can also use built-in copies of frameworks and libraries like TensorFlow, Apache MXNet, PyTorch, etc. as well. But it's really flexible because you can bring your own algorithms. So all the algorithms are stored in containers, so you literally just reference the container if you want to bring your own algorithms as well. You're not locked in at any of these points, so you could just use SageMaker for build, just use it for hosting, or just use it for training, or use it for everything. And then a feature that was released in the middle of this year, hyperparameter tuning. This is an awesome feature. It enables you to set a range of hyperparameters. So remember we spoke about the graphic equalizer, the different knobs that enable you to get a different sound of your music. Think about those hyperparameters. You can set a range of values for each of those hyperparameters. And then SageMaker can go off and will run a series of training jobs that test the range of different hyperparameters and tell you which training job was the most successful. So that saves a lot of time and effort. And that uses Bayesian optimization, so it's a well-respected technique for your tuning. I'll just quickly show you in the console as well. Is it on the screen? Yeah. So as you can see, we have the new ground truth labeling in the console now as well. I'm just going to very quickly show you how easy it is to create a notebook. Select the instance type, and you can use a pre-existing role that you've created, or you can create a new role. And it's as simple as that. And just to show you the dashboard, you can look at the status of your training jobs, your hyperparameter tuning jobs as well, and your inference endpoints, so the predictions that you're making. You've got that nice, easy interface to look at the status of all of those different jobs. Okay. So let's go back to the initial problem that Regit had. So remember my car. Remember Regit. They're the people that serve me. They've got their own challenge about understanding me. And we're going to relate that back to this machine learning process that we spoke about. So remember data ingestion. And Regit's challenge is to provide me with a personalized service, but also to try and predict when their customers are most likely to change their car. So which of their customers are likely to change their car? So in terms of data sources, Peak works with Regit, and they had access to their CRM system. So their CRM system contains 6 million customer records, so a huge amount of data in there. But we also have an organization in the UK called the DVLA. The DVLA is a government body, and they store information about all of the vehicles in the UK. So there's around 30 million records of cars in the UK, vehicle data. And they can provide a publicly available data set, which Peak were able to use, and that contains 47 different fields of information about your cars. So pretty much anything you can imagine, the make, the model, the engine size, the color, the date of registration, the ownership change to a different owner. Pretty much anything you can imagine about the cars. So huge amount of data there. And what they did is they used the interface that Richard has showed you to securely ingest it into S3. And then they needed to go through that ETL process. So remember we spoke about the different sources of data and unifying them into a single data set. They use Spark on EMR. Elastic MapReduce is a big data tool that allows you to easily build scalable Hadoop clusters in AWS. And Spark is a really good data processing engine because, again, it's very scalable, it supports multiple data formats, and it was a perfect tool for them to use to be able to perform this ETL process on this huge amount of data. Because bear in mind, we've got 30 million vehicle records, 47 different fields of information, 6 million customers. There was a lot of data there to ingest and unify, ready for the machine learning models. They then extract it into Redshift. So they use Redshift as their data warehouse because for them, they've got lots of customers with lots of different data types. And Redshift for them is really a good all-rounder. When you're analyzing that data, you're not constrained by primary keys, and you can easily analyze these millions of rows of data. So that's the tool they use for their data warehouse. Once they'd cleaned that data and got it in a state that was ready for their machine learning model, they extracted it into an S3 bucket. And that S3 bucket is ready for their data scientists to use with the Jupyter Notebook. So move to that next phase, the model training phase. This is where the data scientists get involved, and they perform that initial data visualization and analysis. So we saw how easy it was to create that Jupyter Notebook. First task is to select the location in S3 of your data, of your training data set. So they select that data, and then they start to do this data wrangling process, this analysis of the data, looking for patterns in those columns of data that are going to help them make their predictions. And they also start that process of feature engineering as well. And I'll just quickly show you a quick demo in here. So this is an example notebook, and you can open SageMaker and create a notebook, and there's loads of different examples you can use. This is a customer churn example, but I just wanted to show you the concepts of what they were doing. They select the S3 location in here, and then they import the libraries that they'll need to help them visualize and analyze that data. So Pandas is very popular because it enables you to analyze data in a tabular format, so you can see it very clearly. You can use NumPy for scientific calculations. And then you've got libraries like Matplotlib, which enables you to visualize the data in a graphical format as well. And you can see here using Pandas enables them to look at the columns of data and look at the values and start to think about what data values are going to help them make their predictions. So if we think back to the Reddit challenge, they want to find out which users are most likely to change their car. So think what sort of data would be useful for them, the age of the car. That could be a significant predictor. So what they can do is they create a new feature which subtracts the date of registration from today's date, and that gives them the age of the car. They also used a feature hashing trick. So they had lots of categorical data like the make and the model of the vehicle. Now, the make and the model of the vehicle is no use to the machine learning model. It needs numerical vector data. So this feature hashing trick enables them to convert it into a numerical value that the machine learning model can use. And as humans, we like to see graphical representation of things to help look for patterns. So you can use Matplotlib to create some graphs of each of the columns of information to help you visualize the sort of spread of the data and see which columns of data are most useful to you. And often as well, they'll need to drop data that isn't relevant. So they start to look at the columns of data and see which data isn't going to help us. Which data do we need to drop from this data set? And they can use matplotlib again to look for correlations. So they're looking for correlations between the different data sets, so different columns of data. All this analysis takes time and effort, but SageMaker allows you to do this very easily through the Jupyter Notebook. And ultimately, they get to a state where they're happy with the data, and they can start to think about splitting that data up. So we spoke about holdout validation. At this point, they can split that data up into their training data set, their validation data set, and their test data set, and they can export it back out to S3, ready for model training. Okay, so we're now at the model training phase. At this point, they need to select the location, the container location for their algorithms. So the algorithms are all stored in Elastic Container Registry. So the fact that they're stored in containers makes it highly portable. And the options they have, they can bring their own algorithm. They can select one of the built-in algorithms or one of the built-in one of the built-in frameworks as well, like MXNet, for example. So they've got all those different options. In Peak's case, they use their own copy of XGBoost. So they're selecting that location of the container that contains XGBoost. And XGBoost is a very, very popular algorithm. It's basically a highly scalable version of gradient tree boosting. And the idea behind it is you have multiple trees. Your first tree makes an initial prediction, and your second tree will try and address the errors that occurred in the first tree. And then your third tree will try and address the errors that occurred in the second tree. So gradually, as you get deeper into that tree depth, you're eliminating errors. So you're getting more accuracy as you go along. So they use their own copy of XGBoost because they've been working with these algorithms for a long time. They've customized them. They've got their own bespoke libraries that they use as well. They select their training data. And then they're ready to start training. They need to select the number of instances they're going to use. So you can select the instance size and the instance type as well. Obviously, the more and the bigger you select, the quicker your training job. And at this point, they start to tune those hyperparameters to try and get the best possible performance of their model. Ultimately, the output of that training is a model artifact, and that model artifact is stored in S3. And at that point, they're ready to start deploying that model and experimenting with the predictions that they can make. So if they're happy with the model, they can start to deploy it. They select the artifact in SageMaker. They select the algorithm, and the algorithm now becomes their inference algorithm because it's making predictions. So they select the location of the XGBoost algorithm, and they create their SageMaker endpoint. So this is the inference endpoint. So your application or your code that's making a call to that SageMaker endpoint with a payload of data to get a prediction. It calls that SageMaker endpoint. Now, initially, they've done the holdout validation. So they've put their test data to one side. So they can make a call to the endpoint, the SageMaker endpoint, to test how good the prediction capability is with that test data set. Now, if it's good, great. They can look to deploy it into production. If it isn't so good, they go back to the drawing board. They can retrain their model, potentially get new data, and make additional changes as well. And obviously, when they deploy it as well, you can set up auto-scaling, so you can cope with that peak and trough in demand and be able to automatically scale up the underlying EC2 instances to cope with that demand as well. So in terms of Regit, they made a call from their CRM system, but it was published via API Gateway. So you don't expose your SageMaker endpoint to the internet. You can use API Gateway. The scripts running in the Regit CRM system that made the API call to the API gateway. Then they've got a Lambda function running in a private subnet that basically passes that call and invokes the SageMaker endpoint to return the prediction. So everything is protected in a private subnet. The API gateway is the exposure publicly. It returns the prediction data back to Regit. And in terms of what actually happened, what Peak did is they classified the users into distinct groups. The top scoring group was scored as 50% likelihood of changing their car. So Reddit could use this data to focus their efforts and focus their phone calls or their emails on these particular users. The lower group of users, the lowest group, had a 14% chance of changing their car. So it meant that they didn't have to contact those people, and they basically could focus their efforts on the people that had that chance of changing their car. So if you think about it from a personal perspective, none of us like to get phone calls from people that are completely irrelevant to us. If someone had called me at the time, maybe 2 years ago, about my car, I'd have been quite happy. They'd have recommended another car for me to use, but it didn't happen for me. But it was great for Reddit because they were able to do this targeted marketing based on this prediction. Everything in SageMaker is output to CloudWatch, and Peak used this data to look at trends in model performance. So they're constantly looking at the performance of the model in terms of the accuracy. Data changes all the time, so this can degrade over a period of time. So what they also did is they got a weekly import of new data, and they created a new training job, and they went back through this process of retraining the model every week. So exactly the same process as before, create a new model with the new data, see how accurate it is, and then you can deploy that as another model in production. One of the great things about SageMaker is you can do A/B testing, so you can do like a blue-green deployment. So they could use that second model alongside their primary model. So in this case, they're diverting 80% of prediction requests to the first model and 20% to the new model. And they can compare the performance between the two. I'll just very quickly show you a demo of this. So in the Gipsy Notebook, you can see here this is the training phase. And at this point, they're selecting the XGBoost algorithm location. They've defined the training data set and the validation data set. And all they need to do is they've already created the role, the SageMaker role that invokes the endpoint, select the number of instances that you need, the size of the instance, and the output path is the location for the model artifact. And then these are those hyperparameters we spoke about. These are the hyperparameters for XGBoost. You can see the settings here that they've set by default. And then you're ready to execute your training job. You execute your training job, you get a detailed output, both in here and in CloudWatch as well. And then when you're ready to deploy, you call the prediction. It's literally these 2 lines of code to deploy that model, because it already knows the location of the model artifact, and it already knows the location of the algorithm as well. So it's as simple as that to deploy the model. And then you can actually send some test code to make some test predictions with the data set. And this is some example code here, and we can share that with you as well. And the other thing I wanted to show you is hyperparameter tuning. So what you can do is you can create a number of hyperparameter tuning jobs. And what SageMaker will do is take the range of values that you specify and the metric that you specify, the success metric. In this case, for XGBoost, it would be the area under the curve. A value of 1 would be a perfect prediction. A value of 0.5 would be basically like tossing a coin. It's 50-50. So what it will do is it will rank in order which training jobs gave you the best outcome, and which combination of hyperparameters gave you that best outcome as well. Okay. Oh, the other thing I was going to mention as well is the, bear me 1 second. So just wanted to show you the auto-scaling as well. So you can select your numerous variants, model variants. So think about the fact that we did that blue-green deployment. We had 80% of inference requests going to one model and 20% to another. So you set that here, and they're called model variants. So you set a weighting for each of those variants. And you can select a metric for auto-scaling. There's a variety of different metrics you can set. In this case, we've set the number of invocations per instance. So it's the number of requests that are made per each instance. It's a value of 70. And you can also create a cooldown period as well, because the demand to the model can be quite spiky. So you can set a timeout, both scaling in and scaling out as well. Okay, so that was Reddit, and Richard will talk a bit more about the results. But essentially, to summarize, enable them to provide those predictions about the users most likely to change their car. But what it also did, they created some additional models that allowed them to predict the best time of day to call those users, because we all have times of day where we're more available than others, and it meant that they could not bother people at the wrong time of day. So that, again, is contributing to that personalized customer service. So, second problem, remember my trainers. So this was the foot asylum problem. In terms of foot asylum, the problem they're trying to solve is being able to make personalized recommendations to me, but also being able to target the customers that are most likely to make a purchase, because then they target their efforts on those people. They're the people that maybe would want to hear from them. The people that are less likely to make a purchase, they wouldn't communicate with, because they're not interested in making a purchase. So it's a more of a personalized service. And in terms of the data sources, they had numerous data sources for this. So they looked at social media data to look at trends across brand preferences as well. They have a loyalty scheme, so their customers sign up to this loyalty scheme, and it enables them to track their shopping habits. So you think about shopping habits of people, they really vary. So some people don't buy anything for 3 months and then they'll buy loads of things. Some people buy small amounts of things every month on payday. It really varies. So they wanted to look at the different trends of shopping behavior across their customers. They also had information on the email campaigns that they directed to their customers as well. So this was useful in their analysis. And then they had their CRM system. So all of the customers that had signed up to the website, they had anonymized details that enabled them to import some additional data as well. Now, in terms of data ingestion, with this one, GDPR compliance was coming to the fore. So they created an ensemble of models, including random cut forest and several others, that enabled them to scan the data and look for potentially personally identifiable data that wouldn't be GDPR compliant. So they needed to be able to classify that data and ensure that it was being treated appropriately. Again, they used Spark on EMR, exactly as before. And they put it into Redshift for the data warehouse, because again, there was huge amounts of data here to process. And then remember, we spoke about unifying those different data sources into one, and then being able to analyze those millions of rows of data as well in Redshift. And then they extract it into a clean state, into the S3 bucket for the data scientists to analyze. So in terms of foot asylum, again, they used XGBoost. And remember we spoke about model overfitting. Another technique they needed to use here was regularization. So you can use ElasticNet for regularization. And what this does is it imposes a penalty on your model during the training phase that reduces the chance of that model not generalizing properly to the actual real data. So think back to the example of doing an exam and doing your training questions. It's kind of like throwing a curveball in when you're training for an exam. In a similar concept with ElasticNet, in that it was imposing this penalty on the training phase, and that enabled them to more easily generalize that model to the prediction data. So they used the XGBoost algorithm, their own copy of that as well. As before, they followed that same process with the training code. And then they create their model artifacts. So this is the point at which we're ready for deployment. And we showed you in the console how easy it is to deploy. Select your artifact. Select the algorithm, which now becomes your inference algorithm because it's making a prediction. And then you create your inference endpoint. And again, as before, they used 70% for training, 15% for validation. And then 15% was their test data set, which enabled them to check how accurate the model was at making predictions. Again, it's made available by API Gateway. In this case, they built a dashboard for Asylum. And this dashboard enabled Asylum to make calls, like a post call to the API Gateway. It's passed by the Lambda function, which invokes the SageMaker endpoint. And it was returning a prediction on the groups of users, and it would classify the users into distinct groups. The top scoring group had a 75% chance of making a purchase. So what Asylum could do is they could target their efforts and their marketing on this top scoring group. The bottom scoring group had an 18% chance. So again, they're getting these really useful predictions that enable them to contact the right people. So in this case, again, they're pumping out the logs into CloudWatch. They're analyzing this data, and they're continually retraining the model and checking the performance of the data and the trend to see if it's getting more accurate, the model, or if it's losing any accuracy, because data changes all the time. The other thing they did as well is, after the implementation, Asylum signed up to Google Analytics. So this Google Analytics data was really useful for them because it basically enabled them to get more insights into the browsing behavior and then correlate it with the emails that they'd sent to these users. So what they could do is correlate the email campaigns they sent to users and see what effect did this email have on these particular customers. So for example, they could send some emails and it could follow up with some browsing behavior. The user goes straight to the website. The user searches for shoes, etc. So it proved how accurate or how useful the email campaign was. Again, they follow that same process with this new data. They import the XGBoost algorithm. They needed to unify that new data and ingest it into S3 and unify it with the existing data and create a new model and retrain it as well. And then they redeploy and they get more accurate data. And this also enabled them to do a couple of other things that Richard will talk about in the results. But the other thing it could do is they could look at the browsing behavior of the users and then provide a customized web page based on what they've been browsing. So if they've been searching for coats, then their landing page would contain pop-ups for coats as well. So again, it was really personalized to what they wanted to do. And they had a lot of success in terms of the prediction ratio for the users that were most likely to purchase. And this saved them a lot of time in terms of their communications. So in terms of the results, from my point of view, before I hand over to Richard, I've obviously got a new pair of trainers, so it's good for me. I'm going to show you my Regit car dashboard as well. So I've got a new car. I didn't buy it, but I lease it. And you can see how easy it is to use this portal. So I've got all the information I need. I've got my MOT date. I've got my service date, my car tax, obviously due in 2 days, my warranty date, all the information I need in this single dashboard. I can also track the valuation of my car as well. So it automatically tracks the value based on my mileage data as well. It will make recommendations on similar cars that I might like based on my preferences. So all in all, it's a really good way for me to manage my car. And perhaps if I had this a couple of years ago with that other car, I'd have got rid of it sooner because I might have got some good recommendations about alternatives. So I'll just hand back to Richard now. And Richard will talk in more detail about the results for the customers.
Thanks, Dan. Yeah, so I suppose it's always worth coming back to results. What was the impact on a business? I think a good use of AI or machine learning in the enterprise should always have a compelling business case or a use case behind it. And in both these companies' cases, you can see that we've identified one. The results, I think, are really good examples of how transformative machine learning can be to the performance of an enterprise. So in Regit's case, they've achieved a quite staggering 27% uplift in sales from the same volume of leads and the same number of customers. And that's all because they're able to talk to the right people at the right time in the right way And importantly, they're also able to do that at the right time of day. So they're calling and speaking to people or emailing them when those people are more likely to respond to those communications. So they've been able to deliver that result for an improved operational efficiency, and they've reduced their operating costs to service that revenue by 35%. So both of those stats are quite impressive in themselves. And then in Asylum's case, similar really, the uplift in revenues generated from those digital marketing communications has been 28%, which again is phenomenal. That's all been done with a 74% reduction in cost per click. So not only are they able to talk to their existing customers in an enhanced way, which has driven the revenue uplift, they're also able to attract new customers in an optimized way because they understand what new customers are likely to want from the learnings from their existing customer base. So in deploying those techniques in customer acquisition, they've been able to reduce the cost of new customer acquisition by 74%, which is really, really cost efficient for the business. And then finally, we didn't talk about this use case too much today, but I think the sort of retail model of the future will be powered by artificial intelligence. It'll manage both the revenue side of the business, but also the operational side of the business. So we've helped them achieve a 25% or identify a 25% reduction in stock and inventory using the forecasting capabilities that machine learning gives them. So if you think back to the point we were making about the central intelligence system at the heart of an enterprise, there's a good example of one brain being able to control both the revenue and the cost side of a business, and support the enterprise moving forward. So I think Daniel is going to just recap on next steps.
Conscious of time, but a very quick recap really. So just thinking back to what we said at the start, just think about how well you're connecting with your customers, and whether you can connect in a much better way with them and give them a more personalized service. If you're interested in getting started, you can go to this webpage, obviously machine learning. We've also got a machine learning navigate program as well. So this is a series of training and advice on how to build your own ML practice, if you want to build your own ML practice. Or you can talk to Peak, the experts who've been doing this for a very long time as well. And just very quickly, Richard, you're going to talk about your public beta?
Yeah.
So if you like.
So what's fantastic about that is I think Dan's highlighted just how difficult it is to get AI and ML into production in the enterprise. The Peak system is a system that we see as the future of enterprise AI. It integrates a lot of the services that Dan, or all the services Dan has talked you through and more, into one easy-to-use single AI platform as a service. And today we've announced as a business we're making that publicly available for all users to access and to build and train and deploy your ML AI projects into the enterprise yourselves. So it takes away all that complexity. It's designed for engineering and data science teams. It supports our teams do our work for our customers, and it can support you guys too. It allows them to concentrate on the machine learning problem, not the infrastructure and all the things that goes around that. So it makes the team and the effort much more scalable. It makes it much more simple to manage complex issues such as data governance, scalability, security, and extensibility as well. So if you guys are interested in learning more about that, you can go to our webpage, so beta.peak.ai, or you can email us at beta@peak.ai, and we're happy to talk you through that in a bit more detail. So, yeah.
Thanks, Richard. Thank you very much for your time. Please don't forget to fill in the evaluations. If it's good feedback, fill it in. I don't want to go back to that old car again. And any questions afterwards, I think we've hit the deadline, but you're welcome to come and have a chat with us off stage. That's all right. Thank you.
Yeah, thanks.